Hi and welcome back to a new video. If you follow the car scene and maybe also the Nürburgring racing scene, then I'm pretty sure that you know Misha. 3 years ago we built a gaming system for him, and now he reached out to me again because he needs a very powerful system, a powerful workstation for a different project. So here we are building an insane Threadripper workstation for him. This video is powered by Seasonic's Prime TX 1600 watt premium PSU. With a peak efficiency of 94% at 50% load, this PSU is 80 plus titanium and cybernetics titanium certified. I've been using Seasonic Prime PSUs myself for years in extreme overclocking scenarios, and I was never disappointed. All necessary safety features are in place, such as OPP, OVP, OCP and OTP, and will make sure that your system is running as stable and safe as possible. I also find it impressive that Seasonic is so convinced of their own quality that these PSUs come with a warranty of 12 years. That is just impressive. So make sure to check out Seasonic's Prime TX 1600 watt PSU in the link below. If you want to build a very powerful workstation right now, you basically have the choice between Intel Sapphire Rapids or AMD's Threadripper. The thing is, with Intel Sapphire Rapids, the CPUs are much more expensive. For example, we want to go for a 24-core system. And there the Sapphire Rapids CPU costs about 2,500, 2,600 euros, something in that direction. And the 7960X costs like 1,600 euros. There's a big price difference, and on top, those AMD CPUs are much more efficient, like crazy more efficient, which we already showed in the launch review of those CPUs, where we also overclocked it with liquid nitrogen, if you want to check out that again. What you should also keep in mind is that the pricing of the motherboards of AMD platform is typically a little bit better right now, and they're also technologically a little bit more advanced, simply because they're just much newer. So this is the Asus ProWS TRX 50 Sage Wi-Fi. Wi-Fi also quite cool because it's already Wi-Fi 7. That is also the retail version of the board that we used for the liquid nitrogen overclocking. And that's also the first time that I'm seeing personally the retail version with like nice heatsinks and everything, because back then the board we tested was basically blank, like no heatsink, nothing. This is a beautiful looking board, and like the VRM around the socket is just completely crazy. So let's get straight started with the SSDs. We have two Samsung 990 Pro with 4 TB of capacity. We have 3 M.2 slots on this board. The two on the right are PCIe Gen 5 underneath this heatsink, and on the left side there's also a tiny heatsink that covers another slot with only PCIe Gen 4. Luckily, the 990 Pros are only PCIe Gen 4, and personally I think Gen 5 SSDs are not really necessary unless you have a special use case where you can make use of the additional speed. But typically, from all kind of daily applications that I know, you don't really benefit from it. And the PCIe Gen 5 devices just have too many downsides. They just get way too hot, they're more expensive, and especially here, like on the right side, you have 2 slots with Gen 5, which means that you throw 2 SSDs in there with no active cooling could be problematic, and with Gen 4 it's just so much easier because I can put one SSD on the right side and one on the left side. With this type of SSD, as you can see, it's just a single-sided one. You don't have to peel off the protective film of those thermal pads because they won't make contact with the SSD anyway. This is only for double-sided SSDs, unless you want to replace it with a different thermal pad thickness. But obviously you have to still peel it off on the heatsink. And so we can continue to mount the CPU, the 7960X 24-core Threadripper. It really is a beautiful CPU. Now the only thing is not to break the carrier frame. What I find kind of weird and funny is if you look at the pictures of this board online before you order it, it kind of looks like this is a finned heatsink with fins in this direction, so kind of like airflow going through here. And if you see the board live, it's completely different. If you look at the heatsink from the side, you can see that's absolutely not the case. And there is a fan even in the center on both sides to assist the VRM cooling. It was actually not that easy to find RDIMMs in stock. That's a 128 GB kit with 4 DIMMs. 4 sticks mainly because it's just a 4-DIMM board. 128 GB should be absolutely sufficient for what he told me. They sent me an application list and it's like CATIA, SolidWorks, Fusion 360, some simulation software. So mainly CAD applications, and 128 GB from my experience should be more than enough. It's also 6000 C32, so that's sufficient speed as well. By the way, all the components we see right here, everything is purchased from Misha himself. The entire system is going to be custom water cooled, which is why I ordered this EK Pro water block, which is also kind of interesting because it has 2 outlets and 1 inlet, and 1 outlet is always closed from what I understood. I mean, it's clear that this is always going to be inlet. And you can usually use this as outlet, but you could also theoretically combine both outlets for maybe like, I don't know, like half a degree more performance or something like that. But since those Threadripper CPUs are not getting that hot anyway, should be absolutely fine to just use this as outlet. Before that, we have to treat it with a little bit of Charoudin Extreme. With this type of complex and expensive system, I always test everything in steps first before I even consider to throw all of this inside a chassis. So first of all, I just want to test the main components, and for this we have to connect it to a PSU. Theoretically, you could hook up to 2 PSUs to this board, which is not going to be necessary for our operation because the CPU doesn't consume as much power. It's also not going to be overclocked. If you would like to connect 2 PSUs, then there is a sticker on the bottom that explains which connectors you have to use. For a single PSU use, it's actually quite simple because the rest is covered. You just use this 24-pin connector, and this for CPU, this for CPU, and then there is 6-pin PCIe, 8-pin PCIe, and those have to be connected, and then you're good to go. First boot looks good, all the memory sticks are detected, both SSDs are detected. Now I will proceed to update the BIOS first and then start installing Windows. The latest BIOS is installed and also the memory was working out perfectly easy, no problems at all. Expo 6000 C32 with 128 GB. Of course, I will do advanced testing once the full build is done. That is just a quick test, but we see power draw of 300 watt and the temperature just stays at about 60 degrees Celsius. That is perfect. That's exactly what we expect. And also the score in Cinebench R23 with 51,000 points is exactly what we expect. With this information in hand, I know that the base configuration is working perfectly fine. So the motherboard with SSD, memory, Windows, CPU, everything is working perfectly fine. So I can now proceed to put it into the case. We will build everything today in Be Quiet's Darkbase Pro 901 case, which I also used for 2 other videos recently. It's a very conveniently to use case, has a ton of space for the motherboard in the center and also good radiator mounting options, which is something we will need for the 2 radiators I plan to install for the custom water cooling. Everything will be powered by the Seasonic Prime TX 1600 watt PSU, which is definitely overkill for the current state. But the thing is, for the future, as you can see, it also features dual 12-volt high power connections. So if they ever decide to upgrade the workstation, for example, if they have to expand to like a second GPU, everything will be possible with this setup. That's interesting. There's a 90-degree angled adapter included in the PSU. Also with a tiny button. Not sure if that's like maybe RGB or something. I'm removing the included fans. Those will be replaced with Arctic fans later. The radiators which we're going to use are from Watercool. It's their latest gen and they're quite beautiful. Those are only 30mm thick radiators, have some stainless steel in front and on the back. We're going to use a 360 and a 420mm radiator. We will be using this beautiful RTX A6000 workstation graphics card, which is not the latest generation. This is based on the GA102, so it's the Ampere generation, not the Ada generation. I still picked it because for the application they're going to use, this card just has a huge amount of memory. With 48 GB, that is just going to be more advantage over the maybe quicker GPU, because for their typical application with CAD, you don't really feel the difference as much going from Ampere to Ada, but the big memory can be an advantage for the future with 48 GB. This means the resulting heat that is going to be dissipated towards the water cooling loop will be 300 watt from the GPU peak and 300 watt from the CPU peak. But in the typical application, you should not have that. Neither on the CPU nor on the GPU. Worst case, if you're rendering something really, really heavy for a short time period, but from what they told me that should never be the case. So for the typical application, this choice of radiator should be very good for having fans spin at a very low RPM, because it's a thinner radiator with a big fin size, so we don't need a high RPM to push some air through. So in the result, the workstation should be beautifully quiet. It is very convenient that the entire front frame can be removed for radiator mounting. The thing is, I originally wanted to just put the fans on there and then put the frame above it, and then just mount everything with the included screws from Watercool. But these are a little bit too short, like 3-4 millimeters too short. So I decided to get my own screws, that's M3 x 8 millimeter screws, to just fix the fans on the radiator first and then put the frame above it and then fix everything with just the normal, fan included screws. In this kind of mounting scenario, it's often quite useful to not tighten the screws fully, because you can see I can still move it up and down, because while mounting the frame with radiator and fans, it would not be possible if everything is fixed, because it's really tight with the 420 radiator. So that's always one way you can easier mount things. I also already mounted the motherboard and also did the basic wiring, like front panel stuff, USB, PCIe power, 24 pin power, EPS power, mainly for the EPS power reason, because the next step will be the 360 radiator for the top, and afterwards it might be more difficult to access the things on top. For the reservoir and the pump combination, I decided to go to the Watercool shop, because there is a very nice configurator where you can get it the way you need it. So I also decided to go for the natural looking aluminum things on the side. It's a multi-port top, so you can also have an inlet from the top. And then there will be a D5 pump from the bottom. I bought these universal mounting things, which I then can attach to those fan or radiator mounts. So the plan is to have this on the side next to the 420 radiator. So far so good. Pump reservoir combination is in place. It's going to be a little bit tight on the top right here with the two radiators and a pump, but I will surely figure out how to set up the loop. Also, I added a temperature sensor on the outlet of the pump reservoir combination, connected it to the motherboard. So that should be good. And now I think it's time for the graphics card. Obviously, a blower style air-cooled card is nothing I would recommend in nowadays gaming systems, but you have to admit that this is an absolutely beautiful looking card. And I mean, just look at the reflections of this card. Not even sure why Nvidia went with such a design for a workstation graphics card, but yeah, absolutely insane. Very beautiful looking. Also intake from the backside, so there's intake from front and backside for the fan. Only this connector on the back is maybe something we should quickly talk about. Obviously, I know that the RTX A6000 is not the latest gen. This GPU I think is equal to an RTX 3090 Ti, so that's the previous gen. Still, with this included adapter, we are basically forming dual 8-pin PCIe into an EPS connector. And the EPS connector is the same where we have the CPU power delivery on the motherboard. And this single EPS connector is powering a 300 watt TDP card. So, I mean, Nvidia just could have decided to go for dual EPS instead of all the drama that we're seeing nowadays, and everything would have been fine. But well, time to change this card to water cooling. Okay, let's check. Definitely has an aluminum backplate and some thermal pads. With a few changes here and there, this is somewhat like a mix between a 3090 and a 3080 Ti when it comes to the PCB, obviously, due to the high memory capacity. Also the backside is populated, and there are like a few small changes. For example, the power connector that is soldered here and then wired to the back. I bought this EK block for the A6000, and luckily there's also, as I noticed, some kind of fixture in the back for the power connector. Otherwise, this would have been a little bit awkward. So now we should be able to get the card out. I just removed the I/O shield from the back, also loosened the connector in the back. It's always interesting to see with how little volume and space you should be able to dissipate a 300 watt. Then there's this thing again. This is an aluminum piece, milled. NVIDIA, sometimes you guys are just crazy. Sometimes you're not quite there when it comes to the connector, but the design, yeah, not bad. So this is what we will replace with the water block. GPU memory, everything is cleaned. I then have to cut the thermal pads for the GPU water block installation, and I will use CryoSheet on the GPU. 29 × 25 millimeter should be perfect for the GA102 size-wise. I will also tape the surrounding components, so you have those tiny SMDs surrounding. I will use the Kapton tape to cover this, but with the CryoSheet, this should be completely maintenance-free for many, many years. Tape is in place, and in case you worry, I mean, with the water cooler, it will not get hot anyway. But even if like on an air cooler and you would assume that it's hitting like 80 degrees Celsius something, this stuff can, yeah, easily maintain temperatures far over 100 degrees Celsius. The CryoSheets always come in those foils. So especially for this kind of purpose, if you want to just check the size, it's quite convenient. You just place it over there like that, and then this way you don't have to take it out of the foil and risk breaking it, because they can be quite brittle and fragile. And now the thing is, with the graphics card installation, it's sometimes a bit tricky because it can move to the side. Personally, I just take a syringe of thermal paste. I mean, there's always something included in the water block, so I'm just taking that, and then I will put a tiny drop in this corner and in that corner, and this way fix it. And even if this is like going somewhere, like, I mean, it would just go on a tape here and maybe a little bit on a block there. This just doesn't matter at all, but it will help you so much installing the pad. Done with the front side, still have to repeat the same for the back. And I also, yeah, I put a bit more thermal paste just to be sure that it's not going to move once I flip it around for the cooler. This part right here is a pretty cool feature on this block, because you will put thermal paste here, and then this is the back plate. It will make contact on this area right here. And this way just dissipate additional heat from the back plate directly to the water block. Just a quick check in between to see if it's working, and you can see I get an image, so that's all good, and now I will switch it back off. Not fully sure. So the first attempt, yeah, just ignore the reservoir not being filled up, but for testing that should be fine. And so the thing was, when I initially just started, the postcode LED showed 0D, which is a memory thing. I even waited for like, I don't know, 5 to 10 minutes, because sometimes that's what you have to do with Threadripper. But yeah, now with just 2 DIMMs, it booted fine. Not sure. We'll just try to reseat them. Seems like it was just one of those random AMD Threadripper memory instances for whatever reason, but you can see the memory is reseated and I successfully booted. Maybe just ignore the, yeah, semi-filled reservoir for a second. But as you can see in Windows, the full memory size is detected. The card is up and running. Well, it's running in idle, but the temperatures look good as expected, I would say. Just installing the NVIDIA Quadro driver, and then, yeah, finally happy that this beast is up and running. Awesome, awesome. The feeling of relief and success just building this, because, you know, there's always something that can go wrong, especially with the price of those components. And then because it's not mine, if it's mine, then I usually treat it, I wouldn't say like shit, but you know what I mean. But if it's not my hardware, I always treat it a bit different. I'm always afraid that things might go wrong because it's just not mine. But now that everything is up and running, that is really nice. I completed already like 22 minutes of R23 full load in the stability test, just to see what kind of like CPU temperature I can get and if performance and everything is in line. And I can see CPU package power constantly at like 320 watts, so that's perfect. And to just look at the temperatures, CPU peaks out at, yeah, 80 degrees Celsius. Considering that this is full load and this is a status they will usually never approach with what they want to do. They will be far away from this, and even then, I mean, 80 degrees Celsius. That is really good, especially considering that right now in my room it is pretty warm with almost 28 degrees Celsius. And with that we have a water temperature of 36, which is still good, because this is like almost summer conditions right now. And here we have the speeds. So that the CPU is the 140mm radiator in the front which still has plenty of headroom for the fan curve, same as the 120mm rad in the top. Both of them still have like 50% left, and that one would be the outtake fan in the back. So that all leaves plenty of headroom. Obviously, I still need to test the GPU load, and right now VRM temperature is like 60 degrees Celsius as well. Also very important and not to forget is to get the SSDs to the latest firmware. I just finished 30 minutes of Times by Extreme loop testing. The water temperature peaked out at 37 degrees Celsius. It's slightly higher because it's a combination of GPU and CPU load, so the overall load is higher. VRM is a little bit lower because it's not as tight on the CPU. But if we check the temperatures on the GPU, the peak was like, almost 60 on the GPU temperature and like 80 on hotspot. So all of that should be perfect. In case you were wondering why I did not put the graphics card in the first slot, that was mainly because I couldn't fit a DisplayPort cable anymore once it was there. Because for whatever reason, the DisplayPort connections in the graphics card are rather high than usual. So the cable then collides with this thing up there. Yeah, so I couldn't plug a normal DisplayPort cable anymore, which was the reason why I decided to put it in the second slot. But I mean, the Threadripper platform has so many PCI Express lanes that it doesn't really matter. There's still plenty of slots for any kind of expansion if necessary. The Darkbase Pro 901 comes with two different front panels, and I changed this to the mesh one simply to get better cooling rather than maybe like, I don't know, 0.5 decibel lower noise. And if you are curious, this is the Times by Extreme score. Total is 10,600 points, which is a result of about 10,000 in the graphics score of the RTX A6000 and the CPU score almost 17,000 points. Finally done with this beautiful high power and also pretty quiet workstation. No RGB, which is also something different than usual. And also just to give all the information, the fluid I used is just DP Ultra, nothing else. So with this kind of setup, and obviously I flushed the radiators as well before assembly. So with this overall setup, I think they should be able to run this for a very long time, enjoy the performance of this rig. Also, Misha meanwhile launched Vulcan Alpha, which is their new company, and the goal of this company is to develop special tuning parts, such as air channels for brake calipers and also wings for your car. And for this kind of purpose, for 3D scanning, printing, simulations, they will need this kind of workstation. He has a new dedicated video about this topic, and I will link it down in the description below.